Okay, we'll take another example to illustrate this process. Let's take f of x equals 3x squared minus 2. And let's call g of x, let's say g of x is equal to negative 2x plus 1. All right? So we want to form the composition f circle g. Okay? So we write that as f circle g. That means composition. Rewriting this thing, we have f evaluated at g, evaluated at x. That's what that means. So the f function, which is on the outer function, is going to be evaluated at the function g of x. And g of x is going to be the function negative 2x plus 1. So we're going to take the f function, whatever it represents, and apply it to this new input, which is a function in and of itself. So what does the f function do to the input? Well, taking a look at the f function, what it does is 3 times whatever input is given to us, 3 times the input squared minus 2. 3 times the input squared minus 2. Now the input is going to be the g function, negative 2x plus 1. So we're going to square that input and subtract 2. Okay, now remember the order of operations. When we square a binomial, we square the first term, we're going to get 4x squared. We're going to double the product, so we're going to get negative 4x. And we're going to square the last term, plus 1. So we squared the binomial, then we're going to multiply by 3. 12x squared minus 12x plus 3 minus 2. And then we're going to have 12x squared minus 12x plus 1. So the composition gives us a brand new function which is made up of f and g. Okay, now let's look at the reverse composition. Let's go g circle f. So this is a composition in reverse. So what is g circle f? Well, it means g evaluated at f, evaluated at x. Okay? So it's the g function, which says, it's going to say negative 2 times input plus 1. Now for the input, we're substituting f of x. And what is f of x? F of x is 3x squared minus 2. So if we multiply that input by negative 2 and add 1, we're going to have negative 6x squared. We're going to have plus 4 and then plus 1. So what we're going to have here is negative 6x squared plus 5. Now if you notice that f circle g is not the same as g circle f. So composition, we say, is not commutative. Not commutative. That means you cannot reverse the order and expect to get the same thing. Now that's in general. Now there are special cases when you do compose functions and you do get the same thing. But those are only special kinds of functions which we'll talk about later. In general, f circle g and g circle f are not equal to each other. So we'll say f circle g is not equal to g circle f. All right, let's take a look at another example. And when we do so, we'll see a special case of what I was just talking about. Let's consider two functions which are related. F of x is the cube of x plus 1, and g of x is the cube root of x minus 1. Let's form the composition. And you might want to try this at home or wherever you're watching this. So let's do f circle g. Okay, what does f circle g mean? Well, f circle g means f evaluated at g of x. That's what it means. So we take the f function and we look at it, the f function says cube whatever you put in there and add the 1. Now the thing we're cubing is g of x, so we're going to put g of x inside the parentheses. And we're going to go back to say, what does g of x represent? Well, g of x represents the cube root of x minus 1. So we get the cube root of x minus 1 for g of x cubed plus 1. Now when we cube the cube root of an answer, the cube root of a quantity cubed is just a quantity. So what we have here is x minus 1 plus 1, which gives me x. So the composition of f with g gives me x. Now let's go back and do the composition with g with f. So g circle f. What is that going to be? Well, first of all, this means g, the outer function, evaluated at f, which is evaluated at x. Okay? Now the outer function, g, says whatever you put in there, I'm going to cube it and add the 1. The g is evaluated at f of x, and f of x is given by x cubed plus 1. Excuse me, this is a mistake. Let's look at this again. G of f of x means g evaluated f of x. Now the g function is the cube root of input minus 1. The cube root of input minus 1. Now the input is f of x. So the g function takes the cube root of whatever you put in there into its argument minus 1. This, by the way, is called the argument of a function. And instead of just calling it x or some number, we refer to the function or the expression inside the parentheses as the argument of g. And that'll be important later in advanced mathematics. But right now, so the argument is going to be f of x. And the g function takes the cube root of the argument minus 1. Now the argument is x cubed plus 1. And we take the cube root of that quantity. Well, if we evaluate x cubed plus 1 minus 1, we get the cube root of x cubed. And the cube root of x cubed, of course, is going to be just x. Well, here we see that we have found that f circle g evaluated at x is equal to g circle f evaluated at x, and that equals x. So in some cases, composition is commutative for special kinds of functions. So we'll discuss what these special kinds of functions are.